Hi guys. Guess what? We're doing circles. More circles. I made some pretty good circles today, I thought. I mean, look at those. They actually look like circles. So I'm doing a pretty good job. So we're going to turn to page 810, section 12.3. Circles. Go. Okay. 810. Circles. I wonder how many times I could say circles in this math lecture that I'm giving you today. All right. We are talking about portions of our circles today. This little piece of the pie that you see is left, or depending on how you view the world, there's only one piece gone from the piece of pie. That's called a sector. That's a section. That's like they're going to call it a sector of a circle. It just means like a wedge of the circle, okay? All right, then we're also going to talk about what happens when we have just this tiny little segment right here. And then we're also going to talk about how to find out how long it is if you were walking along this circle path and you went from here to here. How far did you go? Okay, not how, I don't think we're, yes, length. Okay, all right, so that's what we're going to talk about today. These are things that you can put on your little card that you use on your test. They're in all of like the flesh-colored boxes that are in the book, okay? So let's start with the first one on page 18, sector of a circle. It's this one. So basically what it means is if I take the area of this entire circle and then I multiply it by what portion I have of the whole thing, that will give me the area of just that little slice, okay? So that's what our formula is. We do the area of the entire circle, which is pi r squared, and then we multiply it by the part of the circle we have, which is the degree over 360. That tells me how much of the circle I have, like a percentage, okay? So let's try example number 1. Find the area of each sector. Give your answer in terms of pi and round into the nearest hundredth. As always, I don't care which way you want to give it to me. You don't have to give me both. You can give me pi or decimal form, whatever you like. Better is fine. Okay, so MNP is our sector, MPN. Okay, so we're going to do the area of our circle. So pi times what's my radius on that circle? It looks like it's 3. Pi times radius squared. We're going to times it by the degree of our sector, which it looks like is, I know that this part right here is 80, but remember yesterday we learned if this is 80 here in degrees, this angle is also 80, correct? So my degree is 80 over 360. Plug that guy into your calculator and you should get 6.28 inches squared. Or if you're leaving in terms of pi, it's 2 pi inches squared, okay? So you do the area of the circle using the radius, and then you just multiply it by the degree of my sector over 360. I think it should be not too bad for you. So let's try another one. Okay, example 1b. The sector there, EFG, is kind of in that blue color. So we're going to do pi times radius squared first. Our radius of that circle looks like it's 6. And we're going to multiply it by the degree. Who can tell me the degree? Good job. The degree is 120. Plug that into your calculator and it says you get 12 pi. Or if you want to do it in decimal form, you get 37.70. They must have you rounding to the nearest hundredth, huh? Yes, to the nearest hundredth. That's why you put that 0 even though maybe you don't need it. You have to put it as a placeholder because they wanted you to round to that position. So you use that as a placeholder. Okay, let's look at example 2. Circle crops. Example 2 is circle crops. There's a plot with a 720-foot diameter. So we're talking about a farm, and this diameter of this particular crop is 720. It's the diameter. There we go. Okay. All right. To the nearest square foot, what is the area that we watered the sprinkler if it rotates through it at an angle of 50 degrees? Let's say the sprinkler is watering and it's 50 degrees. What is this area here that I watered? That's what it wants to know. Okay. Well, we're just going to use our area formula. So pi times what's the radius of my circle? Be careful. Don't let them trick you. They give you the diameter, 720. So the radius would be half, right? Which is 360. And then what was my degree that the sprinkler was watering? 50 over an entire circle. That gives us our percentage, remember? So then we're going to multiply all of that, and it looks like we get about 56,549 square feet. That's a lot of area to cover with the sprinkler. Impressive. I know I'm going kind of fast, but I think this shouldn't be too bad. It seems like it's kind of right up your guys' alley. You just find your numbers, plug them into your calculator, and off you go. Let's look at the next one. Man, this red erase is great. Okay, the next one is the area of that little sliver. You can see there in the middle of page 811. Basically what you're going to do is you're going to find the area of the entire sector and then subtract the triangle, and that would leave you with that little tiny sliver, right? Okay, so the formula is the area of the sector, which I have here in green, minus a triangle. Remember, triangles are base times height divided by 2. All right, so let's give this a try. Example number 3. There's my little sector from A to B, that little kind of like orangey yellow slice. So we're going to find the area of the entire sector first. Pi times what's my radius? 12. What's my degree? Why, man, I wish you were here to tell me so I didn't have to keep turning around. It's so nice when you guys are here. I'm really missing everybody today. I'm having a hard time. Okay, 360. Okay. So when I'm done with all of that, that's going to give me the area of the whole thing. Okay, but that's okay. That's where we're supposed to start. So when we plug that all into our calculator, we get 24 pi. All right. So now my job is to subtract out this triangle here so that all I'm left with is this little sliver that they're asking for. Okay. So we're going to take 24 pi and we're going to subtract our triangle, and that's going to give us our answer. But we have to figure out what the triangle is. So let's take a look at our triangle. Our triangle is a 60-degree triangle, it says, and it has a side of 12. I don't think they give us any more inches. We'll just cut it into 2. We like to cut these into 2. Okay, if this side is 12, can we assume that this is an equilateral triangle? I think so, because it's a 60. Yeah, okay, so we can, if this is 12, this would be a 6 right here, right? So you can use tangent. I don't know if that's what they used. Although they used 30, 60, 90-degree triangle rules. You can use tangent if you like those better. You'll get the same answer. It's the short leg times square root of 3 if you use the 30, 60, 90 rules. So the short leg is 6 times the square root of 3. So that's our height. So base 12, I know I did that really fast, but we've done this a lot, so hopefully you remember how to do it. Base 12 times height, 6 root 3, divided by 2. Oh, boy. Is the area of the triangle. Just a quick refresher. It's a 60, 60, 60. I cut it in half. So if this whole thing is 12, I knew this was 6. Cut it in half, this is 30. So I can use the tangent of 30 as opposite over adjacent, and you should get 6 root 3. Okay, or you can use the 30, 60, 90 rules. All right, so that's the area of my triangle. So when I do that all out, I get that that's 36 root 3. So I'm going to take the area of the whole slice of the pie minus the triangle that I just figured out, and that will give me the area of the little sliver right there, which they tell us is 13.04. Wow, this pen may erase, but it certainly doesn't write. And we label inches is what we're using, squared. Okay, area of the entire sector minus the triangle gives you the sliver. It's nice, right? That's good. Okay, page 812, the arc length. Okay, so the distance, remember I said as you were going along the circle from here to here is arc length. All right, so this is the last thing that we're learning today. All right, so we're going to use this formula here. Remember when we go around a circle, it's circumference, right? So this is the same concept, only because we're just doing here, we take circumference times the percentage of the circle. Up here, we did area times the percentage. Because we just want to know the length there, we do circumference times percentage, but it's the same idea or concept, okay? So let's look at 4A. We want to know how far it is from C to D. Okay, well, we do our circumference formula to, oh boy, wow, this pin is really not working. Nope, can't do it. We're going to get rid of that one. Okay, we're going to use purple. Circumference, 2 times pi times, what's my radius? My radius, I can't find it. We're in my example number 4. My radius is 10. What's my degree over 360? My degree is 90. Plug that into your calculator. It says to give them both ways. Remember, I only make you do it one way or the other, whichever one you like better. And they got 5 pi. Just feet, we're not doing area, so it's a straight just feet. That's how long it was from here to here. If you use decimals, you should have gotten 15.71. Round to the correct one, please. Follow the directions. All right, let's look at B. Example number 4B, an arc with a measure of 35 degrees and a circle with a radius of 3. Okay, I'm not going to even erase this because we just use our same deal here. Okay, so the arc length, which is this blue one here. Okay, we're going to do 2 pi r. Our radius is 3. And our degree, it tells us, is 35. Plug that into your calculator. You should get 7 over 12 inches or 1.83 inches. Remember, it's not inches squared because we're not talking about area. We're just talking about a length of something, okay? And that's it. So, I have something to leave you with. Question. What's the difference between the diameter and the radius? You should be able to get this one, you guys. The difference between the diameter and the radius. Elijah, Jake, are you looking through your books frantically? From this section. It's in this section. The difference between the diameter and the radius is the radius. Goodbye.